Welcome back to Aarambh Dev Hub. This is episode 6 of the Gupti series. For the past 5 episodes, we built a complete backend. Today we switch gears and build the frontend. And we are doing it in Rust. Leptos is a Rust framework that compiles to WebAssembly and runs in the browser. Same language for backend and frontend. Same type safety, same tooling. By the end of this episode, you will have a working UI with a create form, a success page with shareable link, and a reveal page with one-time display and burn notice. Before we build the frontend, quick word. If Rust full-stack development interests you, subscribe and turn on notifications. Join the Discord for UI discussions. Support on Buy Me a Coffee helps fund more content. Links in the description. Let us build the UI. Let us discuss why Leptos instead of React or Vue. First, language consistency. When your backend DTOs are Rust structs and your frontend also uses Rust, you can share type definitions. API contracts stay in sync without manual duplication. Second, performance. WebAssembly runs near native speed. For compute-heavy tasks, WASM outperforms JavaScript. For a secret sharing app, this matters less, but it is still nice. Third, the reactive model. Leptos uses signals, which are similar to React hooks or Vue refs. But because Rust tracks ownership, the compiler catches many state management bugs at build time. Fourth, it is genuinely fun. Writing front-end code with Rust tooling, cargo build, strong types, and no npm ecosystem chaos is refreshing. The trade-off is ecosystem size. React has thousands of component libraries. Leptos is newer and smaller. But for a custom app like Gupti, we do not need pre-built components anyway. We use Leptos in CSR mode, which means client-side rendering. The WASM binary loads in the browser and renders everything there. No server-side rendering for this project. The UI crate lives in the UI folder. It has its own cargo toml with Leptos dependencies. Key dependencies include Leptos for the core framework, Leptos router for client-side routing, glue net for HTTP fetch, glue timers for the burn countdown, WebSys for browser APIs, and WASM baitgen for WASM bindings. We use trunk as the build tool. Trunk compiles Rust to WASM, bundles assets, and serves them during development. The command trunk serve starts a dev server with hot reload. The index.html file is minimal. It just loads the WASM module and mounts the app. Trunk handles injecting the script tags. For styling, we use Tailwind CSS v4. The styles folder contains input CSS which Tailwind processes into main CSS. We run this separately or through trunk hooks. The mainers file mounts the app component into the DOM. This is the entry point. The appers file defines the app component with routing. We use Leptos router to set up 3 routes. The route path renders the landing page. The create path renders the create secret page. The reveal, slug path renders the reveal page. The navbar component sits outside the routes block. This means it persists across all pages. When you navigate between routes, only the page content changes. The navbar stays constant. Inside each route, we specify which component to render. Leptos router handles URL changes without full page reloads. It intercepts link clicks and updates the view reactively. The slug in the reveal route is a dynamic segment. Leptos extracts it and makes it available to the reveal component through params. Before building pages, we need an API client. This lives in API client tarars. We define two async functions. Create circuit takes the secret text and TTL, sends a post request, and returns create secret response or an error string. Reveal circuit takes a slug, sends a get request, and returns reveal response or error string. We use GlueNet for HTTP requests. It provides a clean async API for fetch. We set content type to JSON, serialize the request body with CERD, and deserialize the response. Error handling is straightforward. If the response status is not success, we extract the error message and return it. The UI can then display appropriate feedback. This client module keeps all API calls centralized. Pages do not construct URLs or handle serialization directly. They call these typed functions and work with Rust types. The create page has a form for entering the secret. We use three signals. Secret text holds the terrestrial content. TTL holds the selected time to live. Loading indicates if a submission is in progress. The terrestrial is bound to secret text with two-way binding. As the user types, the signal updates. The character count display shows current length versus 10,000 max. The TTL selector offers options like 1 hour, 6 hours, and 24 hours. Each option sets the TTL signal to the corresponding seconds value. The submit button is disabled when secret is empty, secret exceeds max length, or loading is true. This prevents invalid submissions. On submit, we set loading to true, call the API client, and handle the result. On success, we navigate to the created page passing the slug, URL, and expiry as query params. On error, we display an error message. The create action pattern from Leptos handles the async operation cleanly. It provides pending state and result reactively. After successful creation, we navigate to the created page. This page reads query parameters for URL and expires at. It displays the full reveal link in a styled monospace box. The copy button lets users copy the URL to clipboard. We use the clipboard API through WebSys. On click, we write to clipboard and briefly show copied feedback. The expiry badge shows when the secret will expire in human-readable form. A warning message reminds users that the link works only once. This sets the right expectation before sharing. Finally, a link offers to create another secret. This navigates back to create. The page is simple but important. It is the handoff point where users get the shareable link. The reveal page is the most complex. It handles loading, success, error, and burn states. On mount, we immediately call reveal circuit with the slug from route params. While loading, we show a spinner. If the API returns success, we display the secret. The plain text is shown in a styled container. We also start a 30-second countdown timer. When the timer expires, we replace the secret with a burn notice. The message says the secret has been permanently destroyed. The actual destruction already happened on the server. This is just UI confirmation. If the API returns 404, we show a message that the secret does not exist or was already viewed. If it returns 410, we indicate the secret expired. Other errors show a generic failure message. Notice there is no retry button. The secret is gone after one reveal attempt. Even if the user refreshes, the slug will not exist anymore. The burn timer uses glue timers. We set a timeout that fires after 30 seconds and updates a signal to trigger the burn notice display. Quick recap of this episode. We set up the Leptos CSR project with trunk. We defined 3 routes for landing, create, and reveal. We built a typed API client for backend communication. We implemented the create form with validation and submission. We built the created page with copy functionality. And we built the reveal page with loading, display, countdown, and burn notice. The app now works end-to-end. You can create a secret, get a link, share it, and reveal it once. But the UI feels static. Interactions happen instantly without any visual feedback. That is where animation comes in. Next episode, we add Spanda animations to bring the interface to life. Entrance effects, copy pulses, error shakes, and the dramatic burn sequence. The UI now works end-to-end. If you want to see it come alive with animations, subscribe now. Join the Discord to share your Leptos projects. And support on Buy Me a Coffee. Links below, animation time next. See you in episode 7.